Hi guys, good evening. Start in a few minutes. Let your friends join. Okay, so we'll start. It's today we'll be doing a couple of problems on all the organic stuff we have seen, right? So I think today we'll be entirely spending up with problems only, mostly, right? And next chapter I'll be taking is thermodynamics, right? No, I think I'll take thermodynamics first and then equilibrium, right? Continuously I'll take two physical chapters. And regarding your exams, that is your, you know that you have exam scheduled for 4 months, February, March, April, and May, right? So what we are planning is like how we conducted a previous crash course for your seniors, like say in 1.5 months or 1 month, we conducted almost daily classes. So how they had was like say 1.5 hours or 1.5 hours, 1.5 hours to this chemistry math. So that's how we did it daily, and the daily also they'll have a test. So that's how we planned it. But I don't know how Raghav was planning for you. So I think it'll be almost similar than how is it going to be. And this 1 month, since that you have your CBSE exams already postponed little, right? So I think this 1 month, if you concentrate fully for JE, right, the first attempt on February, I think it'll be a very nice thing. And then obviously we'll be in touch even after that. We can have extra classes. We'll write more tests. We'll do something for the next three attempts, right? So I think this would be a clean approach for your exams. So you'll be, if at all, like even though not daily, maybe Saturday, Sundays, we'll give off at least 5 days, 4 days. We'll have classes. I think from the maybe not this week, from next week maybe we'll be having that, right? So that's giving you a heads up. You'll anyways get the proper intimation from the management, right? Okay, so we'll start. I'll share the screen. So we did, I think, 4 problems last class. We'll just continue. Hope you have your notes with you, right? Your whatever the notes which you have been taking. Okay. So guys, if I have okay, so this is subjected to okay. So tell me what is the major product? Or just draw the structure. I'll give you 30 seconds and then check whether your structure is correct or not when I draw the structure. Okay, I think should have been fine, right? So hope you remember the mechanism, people. This is bromination, right? Free radical substitution, right? Either just instead of this, I would have given just H nu, right? I told you it's just form of energy, heat or light, both can be used, right? And I told you that if it's chlorine, if it was Br, if it was Cl2 instead of this, if you have Cl2, right? So I know that case you will not have much difference between the different products because it is more reactive and less selective. But Br2, on the other hand, is less reactive and more selective in the sense that whichever is whichever is the most stable intermediate, which will be formed in the reaction, right, in the through the mechanism, that's how the product will be formed. So you can see here, anywhere here or here or here, wherever it is, you will see only secondary free radical. But here you have a hydrogen, guys, right? And say here also you have a hydrogen. So that if it removes, I'll be getting a tertiary free radical here, right? So the answer would have been a Br if you would have kept here. That would have been the answer, right? Okay, how many of you got this question right? Anybody got? Hmm? Anybody got this right? Nobody. Okay. What was the problem? Nobody remembered the reaction? Are you guys there? I'm not on mute. Are you guys there? Can you just give me a hint that you're there? Yes, no on the chat or unmuting yourself? Ah, okay. Fine. Cool. Right. So I suppose nobody got the answer for this question. Cool. No issues. We'll go to the next question. So Okay, so this is the end product here, right? Tell me what is the end product. This is a bromide, right? This is a bromide that is reacting with Mg in the presence of ether, and you go for an aldehyde. Hope you remember the mechanism. What happens when I have? I'll not tell you. Right? I hope something you would have got. Okay, so obviously, when I have a Rx, right, when I react it with Mg in the presence of ether, I'll be getting what?
Grignard reagent.
Yes, correct. So I'll be getting RMGX, right? So how will be the structure for the Grignard reagent here? If you check, it will be just in the place of just Br, you put an MgBr. That's it. So the structure after this would have been MgBr. Like that's how the structure would have been. So now you know how to separate the charges. I know RMGX exists as R minus, MGX plus. So Mg here will have a positive charge, right? Okay, and this carbon atom here would have had a negative charge, right? This carbon atom will have a negative charge. Now what you see here is I have HCHO. Now you know what happens when I have Grignard reagent reacting with acetaldehyde, sorry, formaldehyde. What is the answer? What will you get in general? Grignard
Alcohol.
reagents, what alcohol?
Primary
Secondary alcohol.
alcohol.
Yes, absolutely. Right. So now easily you can do this. Now you can go by the mechanism that will be helpful. 1 second, guys. So if you have C double bond O, a H, and a H. Okay, right. Now this carbon atom is gonna come and attack here, and this bond will break. Right. So now you can go for this. So if you have 1, 2, 3, 4. Okay, now in this place, now you are going to have a carbon having the oxygen, so that would have been O minus, right? That would have been O minus, and this has 2 hydrogens. I'll just put it as H2, right? Okay, fine. So then this O minus, obviously you have the H3O plus. Now this would have become OH, right? So if I draw the structure properly, right? So let me start with the CH2OH itself. Let me start here with this. So I have 1 CH2 OH, done, right? Now next to this I have a CH. Now this carbon atom which I'm talking about, right? Now that has a CH, and you can see this is one CH2 and this is one CH3, and I had the same side also. So basically you have one CH2, CH3. Okay, and again one C2H5 here. That is one CH2. Okay, one CH2, CH3 here. This would have been the structure. Right. So anybody got this answer? Anybody?
Yes, sir.
Okay, good. Right. Nice. Okay, we'll go to the next question. Okay. It's better that I can, instead of drawing the structures, let me check if I can upload anything. If you go to the chat, where is the chat? There is no option like that. Oh, only typing messages coming. I cannot upload anything here, I guess. Okay, no issues. Guys, I think we can do this. Let me let me send a picture in WhatsApp in your group. Okay. I think is it okay? Can everybody access their phones right now? Is it fine?
Yes, sir.
Okay. So I will share a question in the WhatsApp group. I would say. Okay. The question which marked 6. Which of the following SN2 reaction is fastest? Hope you're able to see. Right, question number marked 6. Which of the following SN2 reaction is fastest? Okay, can you tell me the answer? They have mentioned it's as SN2. You know what and all matters for SN2 being like the reaction being faster?
So C.
C. Okay, fine. One answer is C. Any other answers? Any other answers, or everybody want to go with C?
Sir, is it C?
Okay, I can see. Right. So guys, so you can see that I have CH3, I mean CH triple bond C minus and CH triple bond CH. Both are going to act as nucleophiles. That's what I understand. Right. Now, when I check these two for the nucleophile, now we know that charged nucleophiles are more nucleophilic than neutral nucleophiles. Yes. So definitely either A or C can be the answers, because there you have a negative charge in the nucleophiles, and in B as well as D, right? You see that I have just CH triple bond CH, a neutral nucleophile, right? So either A or C can be the answers. Now you have to go for the substrate, right?
Oh,
So
sir,
then
it
the
is, sir.
A,
It is, sir.
yeah, the answer would be A, right? So when you go for substrate, I have CH3Br and I have in C, I have C2H5Br, right? So since it's SN2 reaction, we know that lesser bulky group will undergo the reaction faster, right? So obviously CH3 is a smaller group than compared to your C2H5. So definitely A will be the answer for this question, which will undergo SN2 reaction faster. A, because of two reasons. One, I have a charged nucleophile. Second, I have a lesser bulky substrate. Those two are the reasons to this question. Answer is A.
Sir, if
Is
it
it
was
okay?
SN1, would it be C, sir?
If it was SN1, yes. C. No. If it was SN1, yeah, C. Because there you go for stability of carbocation, right? So if I go for stability of carbocation, I have CH3 plus and C2H5 plus. So in C2H5 plus, I have hyperconjugation. Three hyperconjugating alpha hydrogens are there.
Sir, the
Yes,
logic I used was secondary is more stable than primary in that.
both are primary. No, here actually you cannot call CH3 as primary. It's just
Oh, sorry,
CH3
sorry.
methyl group.
Yeah, yeah, yes, sir, yes, sir, yes, sir.
Okay, right? So you can use only hyperconjugation. If you use hyperconjugation, C2H5 plus is more stable carbocation. That way, yes, C is the answer. Okay, right. Next question. This seems like a nice question. Guys, again, a picture is coming in WhatsApp. Just check. Okay, the question is marked 11th question. Four options. You can choose what is it. And yeah, I forgot to tell you one thing, guys. If in the question they are not giving you, this is obviously a nucleophilic substitution. I mean, not this. I mean, whatever you see in the WhatsApp picture, you see is a nucleophilic substitution, right? And if they don't specify anything, that means if they don't specify that it is going to be a SN2 reaction, or if they don't specify that it's going to be an SN1 reaction, right? So you by default it is always going to be SN2. Please remember that. Okay, by default it is always going to be SN2 unless and until they specify it's SN1. You will not go for SN1. Okay, please keep this in mind. Again, I repeat, if they don't specify anything about the mechanism, by default it is always SN2. Okay, right, now you can do this question easily.
Is it A?
A, A, are you sure? What happens like when I talk about the stereochemistry in SN2, right? What happens there?
Inversion.
Exactly.
Sir,
I
it's
have
D.
inversion of conf or D. Yes, I think D is the answer. Very easily I can say. Okay, wait. No. D, or do you have a better answer? Okay, now how do you solve these problems, guys? Right? The easiest way to solve these problems is going for RNS notations. Okay, so just now you said that in SN2 I'm going to have inversion of configuration, right? So if the substrate, that is the reactant, has, suppose for example, R, obviously the product should have S. Or if the reactant has S, the product should have R. That's how it is. And hope you remember how do you go about your RNS notations. Maybe I can help with this, right? Fine. So let me draw the structures. Okay. So I have one CH3 like this, one Cl like this, one pH, and one hydrogen. Okay, let me do the RNS notations for this first, right? So obviously chlorine gets the first priority, pH gets the second priority, and your methyl group gets the third priority. So you have 1, 2, 3, you're going what, like clockwise, right? And there's no need to reverse, I suppose. Hope you remember, when the hydrogen atom is pointing up, or it is wait, when the hydrogen atom is pointing down, or when it is towards you, right? When the hydrogen atom is pointing down, or if it is pointing towards you, at that time you have to reverse. Or if it is going to be in case of Fisher's projection, if it is at the horizontal position, the hydrogen atom, then you have to reverse it. No, in this case you don't have to reverse it, because it is in the away position, like it is pointing away from us, right? So 1, 2, 3, this is clockwise, so R, done, right? So now let me take B and check Chuma randomly how what is it coming, right? Okay, so for B, the option B, if you check CH3, pH, and a H, and here I have an OH. Okay, so now let me put the numbers. So OH definitely gets the first priority, pH gets the second priority, and methyl group gets the third priority. So you're going anti-clockwise, and now what you see is hydrogen atom is pointing towards you, right? So if hydrogen atom is pointing towards you, that means you have to reverse whatever you got. So now you're going anti-clockwise, so it should have been clockwise. So R, so B is not the answer. Okay, so let me check D then, right? So this is for option B. If you want to check for D, right? You want to check for D, where is it? Okay, so CH3, H, pH, and the OH. Okay, 1, 2, 3. I'm going anti-clockwise, and hydrogen atom is pointing away. So this is S. So the answer for this question is D. Okay, so D is the correct answer, right? So it's simple things. Whatever you have learned, it is applying here, right? So you know in SN2 that I'm going to have inversion of configuration. Inversion of configuration, how do you check? Obviously, you should get the, not the exact the enantiomer, right? You should get RNS to be different. That's it. But this will work on and only if this carbon atom containing the functional group, that is, say this carbon atom is containing the chlorine group, right? Only if this carbon atom is chiral, this will work, right? Because obviously you cannot do RNS if it's not chiral, right? But if they're going to ask you questions like this, they will definitely ask you only for chiral carbon atoms. Don't have to worry about it. Okay, so I hope everybody understood the question. The answer is D. Okay, go for the next. Okay, any questions, guys? If you have, you can ask me. I'll go for the next question in the meanwhile. Okay, similar kind of question, I guess. Right. So again, a WhatsApp group, 14th question. It's marked there. Question number 14. So there's a small difference between the previous question and this question, this 14th question. Very small difference. Can you tell me what is the difference? Hmm?
It has something to do with the chirality of the carbon atom.
No, actually the problem is with chirality here, but not exactly what you told.
Sir, is the answer B though?
B,
B, B, B.
uh, B for Bombay, right?
Yes, sir.
I think, yeah, I think B is correct. Right. Yeah.
So because you
Anything?
don't need to consider inversion of configuration here.
Exactly. That's what I'm telling. Because see, like if I draw the structure and show you, maybe you understand. So the thing is, guys, I have I have CH2Cl, and then you can see there is something. That's it. There is a carbon atom here with four other groups. It doesn't matter, right? So you can see this carbon atom is chiral, but this doesn't have the functional group. The carbon having the functional group is this. This is where you will get the substitution happening, right? So what you have to remember about SN2 is that if the carbon atom containing the functional group is a chiral carbon atom, right, then you have to go for inversion of configuration, right? If not, if you see that the next carbon atom is chiral, there you have to maintain retention, right? So in this case, you have to maintain retention. But if this carbon atom was chiral, as in the previous case, then you would have gone for inversion of configuration. Okay, because there is no way substitution happening going to affect this carbon atom anyway, right? So you have retention of configuration if the carbon atom next to the carbon atom having the functional group is chiral, and if the carbon atom having the functional group is itself chiral, then you go for inversion of configuration. Is it okay? Right? Cool. Next question. Okay, there are a lot of questions based on what is that? The reactivity in SN1, but that I think that should be easy. It should be just based on the stability of carbocation. That we have done so many problems, so I am not actually going to it. But this problem you can solve, I guess. No, actually, this also is. Okay, actually, we can do this. Okay, guys, the question is there. 19th question, it's marked. Question number 19. And one more thing, if sometimes they will not mention that it is going to be SN1, but in this case, you can see it's tertiary, right? The carbon atom having the iodine is actually a tertiary carbon atom. Obviously, that will undergo SN1, right? So if it is secondary or primary and they don't tell you anything, it's definitely going to be SN2. But if it's
Yes, sir.
tertiary,
Plus it's
yeah.
H2O, so it's a polar protic solid.
Yeah. That way also you can see. Yes, absolutely. Yes. So you just have to do the dash properly. Dash properly. What is the dash? What is this? What is the double dash properly which you have to do to get the answer? Hmm? What do you have to do?
So ring expansion.
Exactly. Right. So if you do the ring expansion properly, then you're set. Right? Okay. Anybody wants to give me an answer?
Sir, D.
D for dog.
Yes, sir.
Okay, fine. We'll check. Right. So I have is right. This is what I have. 5-membered ring with an I, with one CH3, another CH3. Right. Okay. So obviously this I will move and I'll be getting a carbocation. Can I do that? Oh, okay. Right. So I will be getting a carbocation here. Right. So obviously the ring expansion is going to happen. This 5-membered ring is going to become a 6-membered ring. Right. Okay. So now obviously you are going to break this bond. Right. You are going to break this carbon and this carbon bond, right? And the only way now, there is no question, there's no doubt for you, because this side I have oxygen, that cannot involve in ring expansion. Only this carbon you can attach it here, right? Okay, so let me do this. Okay, so you just remember that I'm going to break this bond and I'm going to make, I make a dotted line, right? I'm going to make this bond. Okay, so hope you can assume what I'm doing. So let me make a 6-member ring first, along with oxygen. Okay, a 6-member ring is there. Now what you see is that oxygen atom is there. Okay, now the question is, which carbon atom is going to get the positive charge? That's the question, right? So you see, this carbon atom had the positive charge, right? And there is, okay, and this carbon atom attached to this carbon atom. Okay, now this carbon atom has broken a bond and I have compensated it with this carbon atom. Again, I repeat, there was a bond for this carbon, right? Now that bond is broken, but for this carbon atom, which is having the positive charge, I have compensated by making another bond, right? So now this, this is the carbon atom which doesn't have any, the broken bond is not satisfied, right? So that carbon atom has to get the positive charge. And where is that carbon atom? That carbon atom is next to the oxygen atom. Okay, hope you understand what I'm trying to say, right? So this is the carbon atom which is going to have the positive charge. Okay, cool. Next what you see, that carbon atom, this bond is broken. Okay, so this carbon atom, the next carbon atom is this, right? To that there is a carbon atom attached. Okay, that is oxygen, first carbon, second carbon has another carbon, that is third carbon. Am I right, or am I doing it wrong? This bond is broken. Say oxygen first, second, third. Oh,
Sir, I didn't understand how you broke the bonds.
yeah, exactly. There is some problem. I'll draw it again. No issues. Wait. Okay. So O. Okay. Okay, one methyl group, two methyl group, and this is the carbon atom which is having the positive charge. Okay. Okay, right. Fine. So obviously I have to break this bond. Okay, now if I break this bond, and obviously, okay, now this is the carbon atom. I have only this carbon atom left, only this carbon atom only to be left, and that has to, oh, okay, okay, I did a small mistake, guys. Small mistake. What mistake I did is, oh, there is, okay, so what I'm going to do is I am going to break this bond. Okay, I broke that bond. So what I'm, but if I, one second, what was there here? This was there. No, if I break that bond, oxygen cannot attack. No, that cannot happen. Is oxygen going to attack? Is that what is going to happen? I think yes, because oxygen has a lone pair, right, guys? Right. So oxygen has a lone pair. I think it is going to be oxygen which attacks the, by breaking that bond. No, wait. Oh, I'm doing it correctly only. What mistake I did? Okay, so I am breaking this bond, right? Oh, no, I shouldn't break that bond. I'm really sorry, guys. Okay, actually, I should be breaking, say this, I should be breaking either this bond or I should break that bond. That's what we generally do. I'm really sorry, guys. Now I got it. Right. So you cannot break this bond because there is oxygen. So definitely you have to break this bond. Right, so definitely have to make this bond, and instead of carbon atom this and this attached, I want this and this to get attached. I hope you understand what I'm telling. Again, I repeat, I am going to break this bond. Right now, if before you break the bond, you see that this carbon atom and this carbon atom are attached together, but after breaking the bond, you can make one more bond where you have this carbon atom and this carbon atom to be attached. Okay, right, fine. Now the posture same holds good, because this is the carbon atom which has lost a bond but which is not satisfied, is it not? Right. So again the oxygen atom is there. The next carbon atom will have a positive charge. Yes, good enough. Right. Now what you see is that uh, this is attached. I mean the carbon atom which is having the positive charge. Oh, am I correct or wrong? I have broken this bond. So this is done. Okay, fine, it's done. Where should I get the positive charge is the question. Okay, positive charge is here. And then the carbon atom having the positive charge. The next carbon atom is having, this is not there, guys. One second. Okay, now okay, again I repeat. So oxygen atom, right? The next carbon atom is having the positive charge, and the next carbon atom to that is having two methyl groups, and the next carbon atom to that is having two methyl groups. That's it. Okay, now instead of this positive charge wherever you have, now you are going to put a OH. Okay, bear with the diagram, guys. So OH, right? And there are two methyl groups. This would have been the answer. So the answer would be what? C. C would have been the answer. Anybody got this? C?
Yes, sir.
Good. So guys, everybody understood how the ring expansion is happening? right? If you have any doubts, you can please ask me. Did you understand? Okay, I suppose that you understood. Fine. Okay, yes, another question coming. Actually, you have three continuous questions coming to you. Actually, at least two questions, I would say. Okay, questions marked 6 and 7. Okay, you have to find the major product in both these cases. Oh, you're not able to see the marked questions, I guess. I think you can see the colored this thing, right? Those questions. You can do the first one first. Okay, guys, what reaction is this? Hmm? What reaction is this? Anybody wants to tell? Both are same reactions. What is the CH3ONA in the presence of CH3OH? What are they trying to tell us? Hmm? Okay, so what happens is, guys, this whenever you see the CH3NA, I mean CH3ONA, but in the presence of, say, when you have RONA, right? When you have this RONA in the presence of ROH, when they give you, right? So basically, you have to understand that it is going, this RO minus is going to act as a base. That's what you need to understand. This is very, very similar to put KOH or NaOH in the presence of ROH. Right? It is very similar. Right? Alcoholic KOH, we say, isn't it? Alcoholic KOH means KOH in the presence of alcohol. Right? So basically, this also will produce the same thing. In this case, it will produce ROK. Right? RO minus K plus. That's what it will produce. Right? So they can either give KOH in the presence of ROH, or say they can give RO minus K plus, or say RO minus Na plus in the presence of ROH. Both means same. What are they going to give me? Tell me. What is the reaction?
Elimination reaction.
Absolutely. Right? This is going to be an elimination reaction. So whenever you see the CH3ON in the presence of CH3OH, right? So it is going to be an elimination reaction. Okay, and one more thing, guys. Okay, so this RO minus can also act as nucleophile. Hope you remember Williamson synthesis. Okay, so this RO minus can also act as nucleophile. Okay, so again, there is a competition between elimination and substitution. Right. So what you do in these kind of cases is that generally, if they don't give you anything, right? If they don't specify anything, right? It is going to be elimination. But again, it cannot be generally considered like that. But you have an advantage because you are going to have the options with you. Isn't it? Option A, B, C, D, you can have, right? So looking at that, you can tell what kind of reaction they want to tell. But if you have mix of options, looking at the temperature also will actually give me. Generally, elimination is favored higher temperature. A substitution is favored at lesser temperature. Okay, remember this, right? In this case, you can easily look at the question and easily see that there's a double bond getting formed. So I can easily say that it is going to be an elimination reaction, looking at the choices, right? But if this is not given, then definitely you cannot tell that. But if at all you have elimination product as well as substitution product in the question, in the options, then you have to look at the temperature, right? If they generally a higher temperature, elimination is favored. Lesser temperature, substitution is favored. Okay, so in this question, you don't have to worry much because the choices are very helpful. You can easily go for elimination. Okay, and again, just like how you have competition between SN2 and SN1, here also you can have E1 and E2. Hope you remember, right? So again, by default, if they don't give you anything, right, it is going to be E2. Just like it's if they don't give you anything, it's going to be SN2. Similar way, by default, it is going to be E2. Okay, right. Now, what are the things regarding stereochemistry with respect to E2 mechanism? Tell me. I just want two words. First one is one rule. Second one is and the second rule. What is that? What is it? Two things. If you have your notes, go through it. I told you mentioned definitely.
Zaitsev rule.
Okay, one is sides of rule. Okay, you have to form more substituted alkene. That works. That holds good for both SN1, sorry, both E1 as well as E2 sides of, right? But there is one exclusively for E2. What is that? What is it? Check. If you have notes, I don't mind waiting. You can just go through quickly. Just turn your pages and tell me if you see it. Nobody knows, or is there
More
anything in the chat?
substituted.
More substituted is what is sides of rule. Other than that, in E2, did you mention anything else?
Anti-leaving group.
Yes. Anti-leaving group, right? It should be the hydrogen anti to the leaving group. Okay, the high. So you're obviously going to eliminate one Br and one H, right? Br anyways it will go, right? Now where should you remove the hydrogen? The removal of hydrogen should happen in such a way that the hydrogen atom removed is anti to the leaving group. That is anti to the Br. That means if the Br is pointing away, right, your head should point towards you. That hydrogen only you should remove and make a double bond. Okay. Now can you answer the question? Right now, in this case, you see that, I mean, we're talking about the first question, Br is pointing away from us, right? So you should have a hydrogen atom which should point towards you. Only that hydrogen you should take. But if you take, what are you violating? If you take the hydrogen anti to Br, what are you violating? Or is it everything is fine? Hmm? Okay, first you tell me the answer. Any answer you want to give me for the first question? Okay, everybody is looking at the question only.
Sir, is it B?
Option B. Yeah, seems right. Okay, so fine, we will do it. So what you have is a 6-membered ring with a pointing away CH3. So obviously the hydrogen atom here is pointing towards us, right? And there is one Br which is pointing away from us, and there is one D, that is deuterium, pointing away from us, and there is one hydrogen pointing towards us, right? Okay, now this Br is going to go, definitely, no doubt, right? Now you have two options of removing hydrogen. One is this hydrogen, that is one of the beta, this is a beta carbon atom, right? Right, this is also a beta carbon atom. Okay, fine. So you have this hydrogen can be removed, or this hydrogen can be removed, right? So now I told you the hydrogen atom which is anti to Br should be eliminated. Now this is pointing away, so definitely, sorry, this is pointing away, so definitely you have to take a hydrogen which is pointing towards us, and this is definitely not the answer, right? So this is the hydrogen we will remove, right? So if you look at the product, right, if you look at the product would have been, and CH3 is still pointing away from us. Okay, right? Now what is the problem with this answer? Tell me. There is a small thing we are violating here. What are you violating?
Sir, the Zait's of rule.
Exactly. We are actually violating sides of rule, is it not? Because if I have removed this hydrogen, that is this hydrogen, if I have removed, what product I would have got is this, right? I would have got one double bond, one CH3, and the hydrogen and the deuterium would have stayed as such, right? So obviously this is a more substituted alkene, isn't it? Obviously you can see this is a less substituted alkene, this has a methyl group, this is a more substituted alkene, but still the major product is this only, right? I told you why, because the anti is more prior, I mean has more priority when compared to sides of product, right? This is the major product. Okay, right? So whenever you have confusion between anti-hydrogen or sides of product, go for anti-hydrogen. And this happens only in E2, right? In case of E1, there is no question of sin or anti, because you know I'm going to form a carbocation, right? So the hydrogen atom can be removed either from the front or from the back. It doesn't matter. Okay, but for E2 it matters. Stereochemistry matters for E2. Okay, same way can you solve the next question? So yeah, answer B is correct. What you B only, no? Yeah, B is correct answer. Okay, can I go to the next question? I've sent another question. I mean, in the same picture itself, the next question. I think this shouldn't take much of a time. Quickly tell me the answer for this. Next, what is the answer?
Sir, A.
Yes, absolutely. Everybody accept with this, guys. A is the answer. Is everybody fine with that? Quickly give me a yes, no. Quick. Is everybody okay?
Yes, sir.
Hello. Okay, 1, 2. Again, 2 are done. How many I have? I have almost 4 more. Yes, guys. Is all of you okay? I didn't understand. Okay, cool. Previous question I understood, Siddharth. Okay, fine. Now this question also I'll do it. No issues. Fine. Okay. So now what you have? I mean, okay. So this is the thing. So you have a methyl group pointing away. You have a Br, sorry, pointing towards us. Both are pointing towards us, and there is this deuterium pointing away, and this hydrogen pointing towards us. Okay, so obviously this Br is going to go, No doubt. Now I'll draw one more hydrogen here. One more hydrogen is here. One more hydrogen is this. Correct? To this carbon atom. Right? Okay. Right. Now you have to remove hydrogen which is anti to Br. Same thing, right? So Br is pointing away, pointing towards us. So this hydrogen you cannot remove. This is the hydrogen you will remove. Right? So what is the product you'll end up with? In this case, you will end up with this product actually, or I can draw again. Right? This is the product. You have one CH3. And there is a double bond, and the H and the D stays as such. That's double bond. Yes, Siddharth, understood? Right? Okay, cool. Very good, very good. Right. Next question. We'll quickly go to the next question. Okay, so the question mark 12. Which of the following alkyl halides can produce only a single alkene product when treated with sodium ethoxide, RONA? Sodium ethoxide is C2H5ONA. That is sodium ethoxide. So you have to get only one, this thing. No major, no minor, only one product. And there are some inside tricks also. Obviously, it's not as simple as that alone.
So is it D?
Option D. Okay, we'll check. Let me see if anybody else gives any other answers. I don't know which is the correct answer. I'm also going to solve with you only. Yeah, first option we'll check is D because that is the first answer which came. Anybody wants to do anything else? Anybody if you got any other answer? Okay. Nobody wants to give any other answer. So I can only check D.
Sir, I think it's C.
C. Okay. Second thing we'll check is C. Fine. So now we'll check C first. We'll check D first. What happens there? Okay, so it's 2-chloro-4-methyl pentane. So it's a pentane. How many? I think I did so much. I know. So 1, 2, 3, 4, 5. Okay, 5 carbon atoms. Second position chloro. Okay, and fourth position I have a methyl group. One methyl. This is 1, 2, 3, 4 here. Me, right? So let me make the hydrogen go, right? So I mean, you can see that you have two types of hydrogen, one coming from this carbon atom and the other coming from this carbon atom. So obviously I'll get two products. One double bond can come here or double bond can come here. So D is not the answer. Okay, hope you understood why. Okay, we'll check for C, right? So it's 3-chloro-2-methyl pentane. Okay, 5, 3-chloro. Okay, 2-methyl, that is 1 Me here, right? So now again, if you see, there is a hydrogen atom here which can be eliminated, a beta hydrogen. Right, or I can remove hydrogen from here also. Again, you'll get two different products. This would have been the major product, this would have been the minor product. Same way, this would have been the major product, this would have been the minor product in this case. So C is also not the answer. Okay, so what do you want to check next? Okay, I'll go for B. What we see what happens, right? So it is again a pentane. Okay, pentane. It's 3-chloro-3-ethyl. Okay, 1 Cl and 1 C2H5. Okay, now guys, obviously Cl will go. Now you see, I have two hydrogens. I mean, I have one hydrogen this side and I have another hydrogen on this carbon atom also, beta hydrogens, and either of the one you remove, you will anyways get the same product. Okay, if you want, I can show it. Right, say I will have C2H5 here. I'll just write it as ET. Okay, now if you put the double bond here or you put the double bond here, I'm going to have the same this thing, right? But what you have to check is you have to check for whether you have any geometric isomerism also in these type of questions. When I say different alkene, I'm also interested in about this thing also. What is that? Isomers also, especially geometric isomers when it comes to alkenes. Now, in this case, you can see there is an ethyl group, there is another group, right? For this car, okay, I'll draw the structure again. Okay, so if I put the double bond here, you have an ethyl group, right? Okay, now if I consider this carbon atom has one ethyl group, another group, some other group, right? But if you look at the next carbon atom having the double bond, you have one hydrogen, right? And one this group. Oh, what do you see? So definitely this can exist in cis and trans. Hope you remember how do you determine whether a particular alkene gives geometric isomerism or not, right? What is the condition? I should have a C double bond C, and I know I have two more bonds. These two bonds should be different. AB, AB. Now that's what you see here. For the first carbon atom for the first carbon atom here, you see one ethyl group, one other group. Again, for this carbon atom, you see one hydrogen, one other group, right? So definitely C is, or B is also not the answer. Even though you give, without the geometric isomer only one, but due to geometric isomers, I can have two products. One can be cis, one can be trans, right? Okay, so obviously the answer is going to be A. So we'll check how it is. It's okay, again a pentane, right? So you have, oops, guys, I did a small mistake. What mistake I did? Tell me. Quickly tell me what mistake I did. Is this option B?
No, sir, because
Yeah,
in one
that
carbon
is,
there are two
it's
similar groups.
correct. So, oh, it's correct only. Oh, it's 3 chloro, 3 ethyl pentane. Okay, okay. I'm sorry, guys. Everything is proper. No issues. No issues at all. Everything is fine. So 3 chloro, 3 ethyl pentane. Correct. Okay. Now here it is going to be 2 chloro, 2 ethyl pentane. Okay. So that means here I have 1 chlorine, and second carbon atom again has a methyl group. So here I have an Me. Okay. Right. So I should go for okay, where do I have to see where and all the hydrogens are there? So again, this carbon atom has a hydrogen, right? Again, this carbon atom also hydrogen. Okay, so that means again I can get one double bond here or a double bond here. So okay, so this question is actually a bad question, guys. This is not a good question because none of the options are choosing. But among the four, if you ask me which is the best option, the B option would have been a better option because at least you don't get a major or minor product like that. You have only one double bond. There is only one place where the double bond can be formed, right? That way, at least I can say that B is the correct answer. But generally, the question is not a 100% correct question. They should have given something else which doesn't have any geometrical isomerism also. That would have been the perfect answer, right? So hope you understand, right? This again can give two places where double bond can be there. But in option B, you see there is only one place, right? I mean, either of the place you take, you are going to get only one product, right? So option B for this question is a suitable answer, but not, I would say, the exact correct answer. Okay, fine. Hope you
Sir, I
understood.
have a
Everybody
doubt.
understood? Yeah.
Sir, there's no possibility of cis and trans here, no, sir.
Okay, we will
Because
check.
when you
Wait,
draw the
1
structure,
second. We'll check. We'll check. We'll check. So you have this one, right? And you made a double bond here, assuming, right? And there is an ethyl group here. Okay, now there's an ethyl group. Now these two, that is these two are the carbon atoms. Oh, okay. Yeah, this is CH2. Correct. Both are hydrogens. No, CH only, right? Correct only. There is one hydrogen, one other group. Again, for this carbon, if you check, one ethyl group, another group. Yes, geometrical isomerism is possible. Not cis and trans, but it will be E and Z. Hope you remember what is E and Z. Just like cis and trans. Yes?
no, sir, I didn't understand.
Oh, see, if I make it properly, I have the C double bond C. Okay, this is the C double bond C I'm talking about, right? So if I take this carbon, right, there is a hydrogen, right? And what is this? This is the methyl group. Okay, right. Now if I take this carbon, you see there is one ethyl group. Oh, again you see there is an ethyl group. CH2, CH3. Again there is an ethyl group. Yeah, this will not show. Absolutely correct. Right? So you see both are ethyl groups, right? One ethyl group is here. Again, you see for this carbon, CH2, CH3, again an ethyl group. Right? So yeah, this will not show geometrical isomerism. Yeah, so option B is the perfect answer. Yes, what you told is correct enough. Doesn't show geometrical isomerism. Okay, right? Good one. Good, good, good. Right. So any questions, guys? Everybody understood what happened? What happened in this question? Right? I suppose everybody is fine. Please, if you don't have any, if you have any doubts, please stop me and ask. Right? Okay. I did not teach you half an elimination yet. Okay, we'll come back to that later. Did I teach you half an elimination? Guys? Did I teach you Hoffman elimination?
No, sir.
Okay, cool. We'll see it later then. Okay, people. I think we said the class is still 6 o'clock, right? What we do is we'll just take a 5 or 10 minutes break. Time is now 5:22. Maybe an 8 minutes break. We'll round off meet by 5:30. Okay. So we'll again go till maybe 6:10. Is it okay, guys? Right. So we'll come back and meet exactly at 5:30. The class will get over by 6:10. Okay. You have an 8 minutes break. Okay. So please be there on time. Right? We'll take a break. Thank you. I'll unmute yourself. I'll be in the screen. I think it's also necessary. It's not necessary. You also have to leave the meeting, right? You can just keep your phone or laptop just open, and you can do whatever you want in the 8 minutes and come back. Okay, fine.
Yes, sir.
Hi guys, I think hope all of you are back. Yes, I'll give you a question. So in your WhatsApp chat, question number 13, which is marked, tell me the final product. What is the major product in the following reaction? Okay, what reaction is that, people? 13th question. What reaction is that? CH3COO twice HgH2O NaBH4 H3O plus. What reaction is that? Hmm? I hope everybody came back, right? Yeah. So what reaction is that?
Sir, is it reduction?
No, just you see NaBH4, that's why you're telling. No, it's not. When you have an alkene, when you have this mercuric acetate, there is a reaction. What is it? So you see there are the products are all alcohols, right? So tell me what are the three ways you can convert an alkene to an alcohol directly? What are the three ways? Mention the three ways. What are the three ways you can convert an alkene into an alcohol? What are the three reactions?
Acid hydration, hydroboration,
Mm.
oxidation,
Mm.
oxymercuration, demercuration.
Exactly. These three other things, right? Acid catalyzed hydrolysis. There you see that I have Markovnikov's product as well as rearrangement is possible, right? And in case of your hydroboration oxidation, you're going to get anti-Markovnikov's product, right? BH3. If you put, you're going to get anti-Markovnikov's product, no rearrangement. And the last one is oxymercuration demercuration. And this exactly is that reaction. You can see RCOO, Hg. I forgot to tell you that you have NaBH4 and H3O plus also in that, right? Just make if you have space, just include that also. Okay, so this reaction here is oxymercuration demercuration, right? So here you are going to get, tell me, Markovnikov's or anti-Markovnikov's? In oxymercuration demercuration. Markovnikov's or anti-Markovnikov's? Go through your notes. You should have written it. I should have mentioned it. Hmm? Okay, guys, searching. right? So if you don't remember, it is Markovnikovs. Okay, so I repeat all the three things. You have acid catalyzed hydrolysis, rearrangement, Markovnikovs, hydroboration oxidation, anti-Markovnikovs, oxymercuration, demercuration, Markovnikovs, but no rearrangement. Okay, please understand that. Okay, it is going to be a Markovnikovs product, but there is no rearrangement because there is no carbocation. Okay, now I think we can answer this question. What will be the answer? Hmm? I'm telling you, it's Markovnikovs and no rearrangement. What should be the product? Hmm. What should be the product? At least you can guess. No guesses. Nobody wants to get the answer. Nobody wants to give the answer. At least you must think something, right? Ah, okay. This could have been the answer. What do you think? Hello. Give me the question. Yes, the question is given. You add water. You just add H2O to the double bond, and give me the Markovnikovs product to that particular alkene which is given in the question. Hope you remember what is Markovnikov's product. The nucleophile will attach to the carbon atom, which is maximum substituted. Right now, you can ask me, sir, both one side I have one CH6H5, other I have CH3. So obviously, the carbon atom having C6H5 is more hindered, that is more bulky than the carbon atom which is having CH3, right? So what should have been the answer? I gave you almost all the answer, almost all the clues possible.
B.
Yes, B is the answer, right? So you can see C6H5, CH, that carbon atom which is attached to the C6H5 phenyl group is more substituted. So there you will get the OH. Okay, so the answer for 13th question, which is marked here, is B. Option B is the answer. Option A you see is anti-Markovnikovs. Option C, again, it is not even an alcohol. And option D, you see there is rearrangement, right? That cannot happen in case of oxymercuration, demercuration. Okay, fine. We'll go to the next question. Okay, everybody understood? Wait, the next question is there. 16th question. Which of the following Grignard synthesis can result in 2-cyclopentyl 2-butanol, butan-2-ol, or whatever it is you want to call it. So try to draw the structure first of 2-cyclopentyl 2-butanol, and then you have to check. Hope you know it's all going to be Grignard reagents with aldehydes or ketones, right? So you know how the mechanism works, and tell me whether you find the answer or not.
Sir, is it B?
Option B. Oh, where is the question? Okay, here. Fine. Okay. First, I'll check option B. Right. Let me see if anybody gives any other answer.
Sir, 16th one only, no, sir.
Yeah, 16 only. 16.
Okay,
Yes.
okay, B.
Okay. Anybody wants to give? Anybody wants to oppose or say that yeah you agree with it? Option B.
So I think it's option B.
Okay, fine. Two options came. Now I can check. Right. Fine. Option B is this. Okay. And then you have okay. So obviously you see that this is the negative charge and this is the positive charge. Now this will attack the carbonyl carbon and this bond will break. Right. So you will have one OH directly coming here, no doubt, right? And then you see here I have a CH, right? Now that is having a CH3, and this you can see is a C2H5. Right? What are they asking? They're asking for 2-cyclopentyl. Okay, so that wait. No, this is not the answer, right? So how do you think? What is 2-cyclo? Okay, if you want to draw the structure of what is asked in the question, you have butanol 1, 2, 3, 4, and then you have 2-butanol, right? And then you see in the second in the same one, you have a cyclopentyl group. Oh, sorry. Wait, if I have to draw it properly. Wait. Okay, something like this. Okay, so is it correct what we have drawn here? There is a CH which is having CH. This is the carbon atom. No, I don't think so. This is the answer. You see that the OH group is directly attached to the ring here, but it is not directly attached to the ring. So obviously B is not the answer, people. Okay. So any of the answers you want to check? Maybe we'll check for maybe A. We'll check for A. What happens? We'll see. Okay. Option A, we are checking, guys. Right. If I check for option A. Okay, this is the negative charge. Okay, I'm drawing it. Okay, plus. Okay, right. So this will come and attack here, and this bond will break. Okay, so you have one OH, right? And you see now here directly that this thing is attached, right, to this. Okay, this is what I exactly have. So is this the same thing? Yes. So option A is the answer. A is the correct answer to this question. Guys, did you get it? If you had gotten the structure correct, 2-cyclopentyl, 2-butanol, right? You can see this is the first carbon atom, second carbon atom, butanol, and 2-cyclopentyl. Done. Correct. Option A is the correct answer. Anybody got this? Option A? Okay, I suppose nobody got it. Fine. Anyways, okay, so 1 second, give me. I just switch on the light. Okay, so you're talking something. I was not there. If you're asking something, I was just going to switch on the light. Okay, so we'll go to the next question. Okay, this is a comprehension type question. Okay. Okay, this is the passage. I will show you. Okay, this is the passage. What is there? And there also need the questions. You have 3 questions to answer. Okay. So yeah, the 3 questions: 21, 22, and 23. Okay, first try to answer 21. Then obviously you'll get 22 and 23. Slowly you do it. I think this question will take the entire time. 6:10, I suppose. If we have time, we'll do one more question. Maybe I can do this. If you want to see the question in a larger screen, I can do that. There's my WhatsApp. Right, so yeah, this is the question. Okay, there are, I think the question is, the 21 is, what is the structure of B? So you have to do it from behind. You can see that 2-methyl propyl cyclohexane, 2-methyl propyl cyclohexane. Hope you know how the structure for that first, right? Take your time. Slowly you do it.
Sir, is it C?
21, no? Where is it? One second. How do you go back? Not this going back. Okay, never mind. We anyways have the things with you. We can go to one more directly. Okay, so fine. So in this question, if you see, guys, right? So as I told you, this is what is called as retrosynthetic analysis. Okay. So what do you mean by retrosynthetic analysis? It means you have the end product, right? And you are going to trace back to what is the reactant by whatever the mechanism you know. That particular process is what is called as retrosynthetic analysis, right? Very important in organic chemistry. If you're going to take your higher degrees in organic or in chemistry, you'll do a lot of this in your theory as well as practicals. Anyways, so we'll go for this. I like this kind of problems very much. Very interesting kind of problems. Okay, so at last you see it is 2-methyl propyl cyclohexane. So let me talk cyclohexane first. Okay, a cyclohexane. So you have a propyl group somewhere. Okay, so you have CH, CH2, CH3. Okay, right. Now they're telling it's not just propyl, it is 2-methyl propyl. So obviously this is the first carbon atom, second carbon atom. So you should have had, this should have been CH2 and this should have been CH. Right, this is CH3. Okay, right, fine. This is the structure, the final structure which they have in the question. Okay, right. Before that, what they are doing? Before that, basically they are doing H2 bar platinum. This is an addition reaction. Normal, when you have an alkene, when you go for H2, you are going to get an alkane. That's what. So somewhere in this compound, right? Somewhere in this compound, you should have had a double bond. That's what I understand. Correct, right? So fine, that would have been C, right? So if C on H2 is giving this, so somewhere in C there should be a C double bond. See, we don't know where is it exactly. We cannot predict it like that. Okay, fine. Now before that, I would have before that you see there is concentrated H2SO4. Okay, so the C is an alkene, right? Now where are you getting the C from? You're getting it from B. Right, and how are you doing it? You're going for H2SO4 and heating. This is basically elimination reaction, isn't it? Right, this should have been an alcohol. Only then if I put a concentrated H2SO4 and heat it, dehydration will happen to form this. Right, so B should have been an alcohol. Right, okay, fine. Now the structure of B is what is required. Cool. Now there is no direct way. I don't think there is a direct way of doing this. Okay, we have to go option by option, right, and see what exactly is happening. Okay, but not only that, there is, you can see that CH3COCH3 is getting added to the Grignard reagent. You can see compound A is reacting with Mg to form the Grignard reagent, and that is reacting with the acetone to form B. Okay, and that is the B which you're talking about, which is undergoing dehydration. Okay, fine. Cool. We'll see how to do it. Okay, if I look at the options, okay, now what they're telling is the C is C10H, how much? 16. Okay, now one thing you can do for first, what you can do is you can go for the degree of unsaturation. I hope I told you what you mean by degree of unsaturation. Number of double bonds or say the ring structures. Okay, so whenever you have a ring, that corresponds to 1 degree of unsaturation, right? Whenever you have a double bond alone, that is one unsaturation. When you have a triple bond, that is 2 unsaturations. When you have a ring with a double bond, then 2 unsaturations. Hope you remember all that. Did we speak about this degree of unsaturation, guys? Did we speak about degree of unsaturation?
So I don't think so, sir.
Okay, fine. So please remember that we know what is unsaturated means. So that means we have a double bond, correct? So by what I'm trying to tell you is, if you look at the formulas, actually you will be able to predict whether I'm going to have double bond or triple bond or whatever it is, right? So what I say is, if you have a C double bond C, that is 1 degree of unsaturation. That means 1 C double bond C is that. If you see that, I'll tell you however it is. Now, if you have a ring, that corresponds to 1 degree of unsaturation. And when you have a C double bond C and a ring, that corresponds to 2. And when you have a C triple bond C, that also corresponds to 2 unsaturations. Obviously, now you from the formula you can predict, right? Say for example, if I have a formula like C4H8, this is a very simple thing, but you can do it. C4H8, you can see it's of the kind CnH2n. Right, so obviously it can be, it should have what, it should be an alkene, or it can be a ring structure, isn't it? Why? Because when I have a C double bond C also, I have 1 degree of unsaturation. When I have a ring also, I have 1 degree of unsaturation. Are you able to understand? Say for example, if it was C4H6, right? Now what is the degree of unsaturation? Degree of unsaturation is 2, because when it is a proper alkane, it should have been C4H10, right? So for 1 double bond, 2 hydrogen atom less, it would have become C4H8. 1 more double bond, 2 more hydrogen atom less, it would have become C4H6. Right, now what are all the possibilities that you will be able to get two two unsaturations, either when you have this, when you have a triple bond in the compound, right, or when you have this probability, that is when you have a ring along with that. When you have a ring along with it, I have a double bond also, right? So now if you look at this particular thing, it is C10H16, right? So if it was normal alkane, right, it should have been what? It should have been CnH2n plus 2, right? So it should be C10H22, correct? Right, C10H22 it should have been, right? So if I reduce 2 more hydrogens, it will become C10. So this has 0 degree of, okay, let me actually make some space. Okay, so this has 0 unsaturation. C10H20 would have had 1 degree of unsaturation. C10H18 would have had 2, and you have C10H16 would have had 3. Correct, right? So that's the thing. C10H16 would have had 3. So obviously this particular C10H16 would have had, not would have had, will have degree of unsaturation to be 3. Now what can be possibilities? Definitely there is 1 ring, because you can know that there's going to be cyclohexane involved. 1 ring gone, right? Another way, you see that there is going to be 1 ring, 1 answer. You should have to account for 2 more, right? So obviously there is no possibility that I can have a ring with a triple bond. It's not possible. Hope you understand. Ring with the triple bond is not possible at all. You will violate the tetravalency. Okay, so what is the possibility? The possibility can be 1 ring plus 2 double bonds. This would have been the possibility. Okay, and you see in your what is the last one? Last one is 2-methyl propyl cyclohexane. There are no double bonds. Is it not? In the last product, 2-methyl propyl cyclohexane, there are no double bonds. So there should have been 2 double bonds, which should have been gotten with this reaction, which should have been gotten cleaved with this reaction. So basically, it's not just 1 hydrogen; it is 2 hydrogens here. only then I'll be ending up with this compound. Okay, right? So 2 double bonds I need to have. So what I understand is in B, there is definitely a OH, right? And obviously that if it undergoes, what is that if it undergoes the dehydration, 1 C double bond C, right? But I have to account for one more C double bond C because you see that the degree of unsaturation is 3. One with respect to the ring and 2 with respect to C double bond Cs. Okay, so this alcohol D would have undergone dehydration to give 1 C double bond C, and there should have been here itself, there should have been one OH, one C double bond C. Yes. Okay, in this B, definitely it's an alcohol, and that alcohol on dehydration will give C double bond C. But the product I see there are 2 double bonds. That means along with OH, there should have been one double bond, one C double bond C. That's what I'm trying to say, right? So if you look at the options, what can you eliminate? You can definitely eliminate B from this, isn't it? B cannot be the answer. Hope you understand, because there should be one OH and one C double bond C. B doesn't have anything, right? Okay. Now we have to go for other. We have to check for other things. So these are the information till now we got, right? There are still more informations. Okay, fine. Now what I understand is, now if you look at the question, you have the Grignard reagent, right? Now that Grignard reagent is reacting with ketone, acetone, right? So what kind of alcohol you'll get? Tell me. I
Secondary.
have. Are you sure?
Sorry, sir. Tertiary.
Correct. When you have formaldehyde, primary, any other aldehyde other than formaldehyde, secondary, any ketone will give you a tertiary alcohol, right? So that way again we can check. So check for tertiary alcohols. I think the answer is done, right? What is the answer now? Tell me quickly. What is the answer for this question? 21. Now I told you that it is going to be a tertiary alcohol and it should have a double bond. Which is the answer then?
C.
How C? C is a secondary, right? See, if I draw the structure, maybe you'll understand.
So, okay, sir. It's D.
D is the answer, isn't it? So if you look at D, okay, this is the cyclohexane. There's a double bond as the requirement, and okay, this is the thing, and you have one OH, right? So this is the carbon atom having the functional group. So it should be attached to 3 other carbon atoms. Only then it is tertiary. 1, 2, and 3. So option D is the required answer. Now, guys, I want everybody to say me whether you understand or not. Just give me yes or no. If no, again, I'll repeat.
So can you repeat it? Sir?
Why not? Why not? Sure, wait. So what do you understand? Whatever, let me go here. Okay, I think I'll draw it again. Wait. So we'll go back to the question. So I have B, right, which is having H2SO4, and I'm heating it. So this they're telling is C, which is C10H16, right? And that on reduction, that is H2 bar platinum, is giving this particular structure, that is 2-methyl, whatever the product. Okay, so it is 2-methyl propyl cyclohexane. Okay, fine, no issues. Now, first we'll look about this, right? It's C10H16. Right. Now, did you understand the degree of unsaturation part?
Yes, sir.
Okay, so this has 3 degree of unsaturation. Okay, so obviously what is the one? There can be only one possibility, right? Only one possibility is this 3 can be 1 ring and 2 C double bond Cs. Okay, this is fine. Right. Now you can see that this is H2SO4, and on heating it is giving me an alkene. Right. So definitely this B should have had 1 OH. group. That would have basically given me the dehydration product to give one of the C double bonds. This ring is already there. This has already one ring also. So definitely, right? So one ring, this U will give me one double bond. So, but I need to have two double bonds. That
So one more
means
C double
I
bond.
should definitely have one more C double bond C in this already. Only then I'll be getting two more, two C double bond Cs. Okay, right. Now with this information, like if you look at the answers, choices, right? So you should have one ring, one OH, and one C double bond C. So I can neglect option B for sure because option B doesn't have a C double bond C. Correct, right? So either options can be either A, C, or D. Okay, now only this much we can say. Now, before this, right, before this B is formed, what you have is you have an RMGX, right? And that is reacting with CH3, CO, CH3. Okay, so you know how the mechanism goes. You have the R minus coming and attacking here. So obviously you will form a tertiary alcohol. That's what you need to understand. Formaldehyde will give me primary. Any other aldehyde other than formaldehyde will give me secondary, and any ketone will give me a tertiary alcohol. Correct, right? So this B should have been a tertiary alcohol. That's definitely for sure because from the previous reaction I'm telling Grignard reagent, Grignard reagent with the ketone will always give me a tertiary alcohol. So this should have been a tertiary alcohol, right? Now look at the options. Where do you have tertiary alcohol? You have only in option D, right? You can see this is the structure. Maybe I can show you. Right? This is the structure of option D. It's the tertiary alcohol. So that's why it's the answer. Yes, everybody understood?
Yes, sir.
Okay, guys, everybody please give me a yes.
Yes, sir.
Yes, sir.
Okay, 2, 3. Okay, 4. How many are there? Okay, that's it. Oh, one more guy went. Okay, cool, no issues, right? So everybody here who has understood. Okay, now we'll go for option. Second question. That is 22nd question. What is the time? Okay, so we almost crossed time, but still we'll just finish these two quickly. Okay, 22nd question. Maybe 23rd will take as a homework. Maybe you can do that. 22nd will complete here. So now you know what is B. So with that, you have to get what is A. And with that A, you have reactions happening. Good question. It's a very good question. Okay, any answers, people? At least now, if it have this time, if it have gotten at least A, you did a good job.
Sir, I think
What
it's A.
I mean, the structure of A, or you're telling the option A is the correct answer?
Option A.
Okay, option A is the correct answer. Fine, we'll check it. Right? Anybody wants to oppose or agree with whatever she said? A, did you get something else or the same thing? Okay, fine. Cool. So let me start with B. This is the structure of B. Let me draw the structure again. Okay, this is the cyclohexane ring. Okay, and instead of drawing the this thing alone, I'll draw it in terms of CH2, CH3. So this is CH2. Okay, this is CH2. And then CH, OH, and this is a CH3. Oh, there's one more CH3. CH2, yeah, there is one more CH3. Okay, there is one more CH3 also. Cool. So people, what do you understand? Right. So you see from the question, there was a carbon C7H11Br, right? Now that is forming the Grignard reagent and it's attacking with acetone, right? So obviously you see in the compound A, you had 7 carbon atoms, and in compound B also, compound B, you will see there are 10 carbon atoms, right? Compound A has 7 carbon atoms, compound B has 10 carbon atoms. Obviously, where is this coming from? It is coming from CH3COCH3. These are the 3 carbon atoms is getting added to this from A to B. Is it not right? So if there was a this thing R minus MgX plus, now this R minus would have attacked here, right? So now what will you see? You will see that CH3 CH CH3 and your R coming. Correct? Right? Now let me just trace what I have. You have CH3COH CH3 here. Correct? Right? CH3 CH3OH. Same way. CH3 CH3OH. Okay. Now what would have been R is whatever is remaining, right? So what is remaining? This is the R which is remaining. Okay, so this is my R minus whatever I'm talking about. Okay, so that's it. We have got the answer. So basically, this would have formed the Grignard reagent. So this would have been minus and MgX plus. So if I draw it properly, you see that a 6-membered ring, right? And this is having a CH2 minus MgBr would have been the Grignard reagent. What would have been A? Obviously, you just have to remove the MgBr and put Br. That's it. That's how you form the Grignard reagent, isn't it? So easily I can say that this would have been Br. This is my compound A. That's it. Anybody got this? Anybody got this as the structure for A? Okay. Everybody understood how I got this as A?
Yes,
Yes?
sir.
No? Okay, pretty easy. I'm just telling the normal reaction CH3COCH3 with RNGX, right? So you see they will form CH3CHOH with an R. So CH3CHOH is here, the R minus is this part. And obviously this would have been the Grignard reagent. Instead of MgBr, I put a Br. That's it. That could have been my compound A. Now the other processes are very easy. Now tell me, to this, if I put LiAlH4, what reaction will happen? What is the name of the reaction? From this, what will I get? From LiAlH4, what will I get? I told you we'll get something. What is it? Hope everybody is there. Nobody left. Okay. Fine. Tell me, guys. If I have, oh, I think something is there in the chat. No. Okay. Right. Tell me, guys, from LiAlH4, what will we get? One species we'll get from LiAlH4. What is it? What is it? Okay, tell me what is the full form of LiAlH4? What is the name of LiAlH4? From there's the hint there.
Lithium aluminum hydride.
So what are you gonna get from LiAlH4? The name itself tell you. No. From LiAlH4, you'll get a species that will go attack the substrate. What is the species which will come here? Lithium aluminum. What is there?
Sir, methyl cyclohexane.
No. That's the correct. I'm going to get a cyclohexane here. Good. Methyl cyclohexane is the answer. What am I getting here? In this from LiAlH4.
Hydride.
Thank you so much. It's H minus. That's what you get. Right? So you get H minus. So you see there is a Br minus. So this will undergo nucleophilic substitution. Okay. Now remember, whenever you have Rx, when you have LiAlH4 or even NaBH4, they supply the hydride, which is going to act as a nucleophile. So nucleophilic substitution reaction will happen. Right? So now you will see, yeah, I'm going to get methyl cyclohexane, CH3. Right? Then what they're doing? Oh, there's a double bond, which I missed. Right? There's a double bond here from option. You can see here. Oh, sorry. You can see in structure B, there is a double bond. Right? There is a double bond. You see that double bond I missed. So that also I will draw. There's a double bond here. There is a double bond here. Okay. Now what is the next reaction? Tell me. What is the next reaction? B2H6, that right? B2H6H2O2 NaOH. What is the reaction?
Hydroboration oxidation.
That's it. Hydroboration oxidation. So you're going to have addition of water, anti-Markovnikov's product. Right? So that's it. You have to remove the double bond and add water, and you have to make sure that it is anti-Markovnikov's. Anti-Markovnikov's means you are going to get OH here. This is the answer. What is the answer then? You have two options matching, and I have to go for what is it? Syn or anti-addition. Oh wait, this is a syn addition or anti-addition. Oh my god, so much details. I think it is syn addition. It cannot be anti-addition, I guess. Yeah, B2H6 will be a syn addition, guys. Please make a note of it. If you go to hydroboration oxidation, write a note and say that it is going to be syn addition, right? That means either both of them should point away or both of them should point towards me. That's how it is. Okay, so answer would be C. C is the correct answer for this question. Okay, C is the correct answer. I think everybody understood. LiAlH4 is simple, nucleophilic substitution. Then hydroboration oxidation, that to this double bond, add the alcohol, add the water, you will get syn product. Simple. Okay, so I hope everybody understood. This was a good problem solving session, I suppose, right? Okay, guys, I have taken so much of your time. I'm really sorry. You can go enjoy your weekend, right? Thank you so much. We'll meet again next week.
Thank you, sir.
Thank you, sir.
sir.
You.